Welcome dear students to today's session of Summit for Max. Subscribe to the channel and press the bell icon for further notifications. Let's get started. In today's session of Integral Calculus, we have the problem the elasticity of demand with respect to price for a commodity is given by 4 minus x by x, where P is the price when demand is x. Find the demand function when price is 4 and the demand is 2. Also find the revenue function. Given that the elasticity of demand is equal to 4 minus x by x, we know that neta d is equal to minus p by x into dx by dp. So equating it to 4 minus x by x and x gets cancelled on both sides. So dx by 4 minus x is equal to minus dp by p. Separating the variables, we get this. Now integrating on both sides, we get log of modulus 4 minus x by minus 1. The internal differentiation is equal to minus log p plus log c. This negative sign will get raised to the power. So we get log of 4 minus x to the power of minus 1. And on the right side, we get log c by p. Let us cancel log on both sides. So we get 1 by 4 minus x is equal to c by p. Let us cross multiply and we get p is equal to c into 4 minus x. We are asked to find the demand function when price is 4 and demand is 2. So let us substitute the respective values in 1. When x is equal to 2 and p is equal to 4, we get 4 is equal to c into 4 minus 2 . So we get c is equal to 2. Therefore 1 becomes p is equal to 2 times 4 minus x. So which can be written as 8 minus 2x. Therefore the price is equal to 8 minus 2x. Now let us find the revenue function r is equal to p into x. So 8 minus 2x into x, which gives 8x minus 2x squared. Hence the demand function is 8 minus 2x and revenue function is 8x minus 2x squared. The next problem for today's session is a company receives a shipment of 500 scooters every 30 days. From experience, it is known that the inventory on hand is related to the number of days X. Since the shipment I of X is equal to 500 minus 0.03 X squared, the daily holding cost per scooter is rupees 0.3. Determine the total cost for maintaining inventory for 30 days. Here we are given that the inventory on hand I of X is equal to 500 minus 0.03 X squared. Holding cost C1 is equal to rupees 0.3. And the time period T is given to be 30 days. So the total inventory carrying cost is equal to C1 into integral of 0 to T I of X into dx, which is equal to C1 is given to be 0.3 integral 0 to 30. I of X is 500 minus 0.03 X squared into dx. Now let us integrate. We get 0.3 into 500x minus 0.03 x cube by 3 within the limit 0 to 30. Let us substitute the upper limit. So we get 0.3 into 500 into 30 will give you 15,000 minus here 3 and 0.03 cancels and we get 0.01 into x is 30. So 30 cube. So the next step we have 0.3 into 15,000 minus 0.01 into 27,000. So we get 0.3 into 15,000 minus 270, which is 0.3 into 14730, that is 14,730, which is rupees 4,419. Hence, the total cost or maintaining inventory cost for 30 days is equal to rupees 4,419. The next problem for today's session is an account fetches interest at the rate of 5% per annum compounded continuously and individual deposits rupees 1,000 each year in his account. How much will be in the account after 5 years? Given e to the power of 0.25 is equal to 1.284. Here we are given that P is equal to rupees 1,000 and rate of interest R is equal to 5 by 100. So 0.05 and N is 5 years. Amount after 5 years is equal to integral 0 to 5 1000 into e to the power of 0.05 x into dx. We know the formula for A as integral 0 to n p e to the power of rt into dt. So now let us integrate. We get 1000 into e to the power of 0.05 x by 0.05 within the limit 0 to 5. So we have 1000 by 0.05 into. Now let us substitute the upper limit and lower limit. We get e to the power of 0.05 into 5 minus e to the power of 0. So which is 20,000 into e to the power of 0.25 minus 1. We are given that e to the power of 0.25 is equal to 1.284. Let us substitute and simplify so that we get 20,000 into 0.284, which is equal to rupees 5,680. Hence, the amount after 5 years will be rupees 5,680. Hope the session was interesting. For much more, please subscribe to the channel Summit for Max. Thanks for watching.